Okay, this is a bit of a dull one, although very important, and I sort of slightly neglect this on a lot of my camera tracking and stuff, but it is super important. Is you really need to get rid of the lens distortion, and even if it's slight, it means if it's slight, it means your geometry won't stick exactly towards the corners of the picture or video or whatever. So I've been trying to find a way of using open source software to do this, and you can use Hugging to do lens calibration to give you we need these two values called K numbers, which are like the barrel distortion. So I was trying to use Hugging, and then I couldn't really get that to work. Where you draw lines and then it gives you the values. It's really the format I was struggling with because and then there's also Metashape, a lens calibrator or something, and that also gave me all the value. You just like feed it. In that one, you just feed it a sequence of checkerboards from different angles from your camera. And then it will figure out all the K values. But the lens models seem to be different. But by that I mean we have, if you go to, see here, I've managed to get rid of it. We have in your tracking, when you load the clip in, you've got under lens, you've got lens distortion, and the only one I can seem to get work currently, and I would appreciate if anyone in the comments can get other ones to work with other lens models. The only one I can really get to work reliably at the moment is nuke, which means I've got like the non-commercial version of nuke, and I can get this to work. And I use nuke professionally when budgets allow. Just quickly how I do it. I mean, we still use non-commercial because we just need those K values, right? K1 and K2. And the center thing. So the way it works is you just drop down a lens distortion node, hook it up to the footage. So if you haven't never used Nuke before, tab, you want to press R for read. He says. So you can just press R, and then that will go off and find a JPEG, pull that in, and then tab, and then we want lens, and you hook that up like this. Okay, and then it's 1 and 2 are like your viewers, right? So it connects to the little viewer node, and that will show you in here, right? So just double click on the lens distortion thing and go to analysis. And what we do is you just click on this and you draw lines, not like that, obviously matching horizontal, and then click off, click on again, and vertical, and you end up with something like this. Okay, so you draw that, you end up with these 4 lines. And it doesn't obviously have to be a grid. It could be a fence or a brick wall or something. That's the cool thing about this. So then you hit analysis, solve, and off it will go. He says, and has it done it? Well, it would have done it. So then it will go understort, and it will go and it will give you these 2 values here. As it calls it, the terminators. And these are the 2 K numbers you need. And the center, right? And so it all sounds a bit complex. There's 4 numbers you need, right? And this is using the nuke classic thing, right? So this is what will happen when you hit solve. It will suddenly go to like this, right? So now we have these are the 4 pieces of information we need. I saw someone doing this with 3D Equalizer has a lens calibration thing in it, which can go a lot more in depth and a lot more sophisticated undistortion. But this is it's just simple undistortion thing, and presumably you can do this in maybe Lightroom as well or Photoshop. I'm not sure if it gives you the K values and what particular because there's a number of different. You see here we've got a few different. Here's 3D Equalizers models, lens models, but I'm just sticking with Nuke Classic because this is what I've got it to work. Yeah, so we have these values, and then we go over to Blender, and then you put the determinator values 1 and 2, K1 and K2, and the optical center, right? So just quick, so 2K values, S and whatever these ones here, and that works, right? So then you only see that looks identical to what we're getting in Nuke, right? So that's like the first That's how you just do. But the problem with lens distortion is you need to see the full frame, because you can see that's quite a bit different from how it was. So image editor from that, right? And we're zoomed in and we're losing all the edges, right? So we need all the edges. This is quite an extreme example. So how do we do that, right? Is the thing, because what we ultimately need to do is write out an underdort with like a full gate, so we can see the entire all the pixels, and it's that we 3D track, and then we can crop in, and or we can redistort back and then crop in and all the rest of it. But we need all the pixels, right? So the way we do that is in the compositor. This is quite complicated. So yeah, in the compositor we add the and I was looking at this for the ages for the underdort node. It's not called the underdort node, just confusingly. It's lens, or rather movie. I think it calls it movie distortion is the one we want, right? Okay, so you make that, and then you select the clip that we want, right? And because it's in the tracker, we've defined these values here. This will apply the underdort. So we just hook this all up and just connect it to the viewer, right? Shift this back to the. So that's like. So why does that not work? Oh, it's because I'm a compositor viewer. He says. Oh yes, we need to set that to viewer node, right? So, oops, that's annoying. You should have just like that. So what? Hang on a sec. Oh yes, I need to set the. He says. So that's what it will look like. Let's get rid of those. So yeah, we all lovely understood. As I say, it's reading the lens underdort information that you had in the tracking part, right? And so the thing is, we need to see the full frame outside that. So to do that, we go. I created. Yes, again back to nuke, and you'll see it has bounding box, right? If we go 6,000 by 5,000, so currently you can see here we have 4,000 by 3,000 pixels, right? So 6,000, you can see the bounding box is massive. It's a lot bigger, right? And that contains the complete undistorted thing. So that's what we want that's what we need to composite the underdort in to get the whole underdort, right? So back to Blender. So I've created an image. So I want new image, or image new, and then typed in, as you see, 6,000 by 5,000. Okay, great. And then what we do is we just add a mix node and we mix them together, right? So then it looks like this. And that is the complete, and it's a bit wonky because the center, if we go back to the center of the distortion is offset, right? Because it's like the GoPro lens isn't exactly in the center of the sensor. I mean, that's what nuke is determined. There's a slight offset. So that this final output, back to the image editor. This is what you track. You might want to put a mask on everything, but you need to track the entire thing. And then when you render the 3D will be all over the entire stuff, and then we can distort it back, and you won't have any holes. This is quite an extreme example. But it is super important. I sort of gloss over this on a lot of the tracking thing. Like I don't bother normally doing the distortion, but when the geometry doesn't stick or doesn't line up properly over frames, this is the reason. You need to take the lens distortion out. So as I say, the way to do it: go into nuke, use the underdort. Just quick recap: use the underdort thing, analyze, draw the lines on, solve. It will give you these values: the 2K numbers, the lens information at the center, and then the bounding box. So with the bounding box, then in Blender, just to, obviously you create a new image with the bounding box size of the 6,000 by 5,000 or whatever, and then you composite the undistorted footage using the undistortion, using the movie or the lens. What's it? Movie? How's it called? Movie distortion. Okay, if you type, even if you type in distortion, I don't think it comes up with distortion, does it? Oh, yes, there you go. Movie distortion. Connect that up, and that reads, and also put in the values in the tracking. This is a bit all over the place. Put those two numbers in, and put the optical center in, and then composite them together, and this is the final result. So this is my sort of very, yeah, it's just, but you do need to do this because the 3D isn't magically going to stick to fisheye stuff. You have to distort it back normally is how it works. So this is how you do it. I just wanted to do it because I've been trying to find a video specifically on this, and to try and just use open source or Blender. But the easiest way. I mean, as I said, did look at Hugging. But I was just a bit like, this isn't very intuitive, and I couldn't get the lens model didn't look. I couldn't get an appropriate lens model to work, and the only one that I can currently seemingly get to work is the nuke one. I can't seem to get these other 4 types. So if you go in here, this has got 3K numbers for more fancy, obviously more sophisticated stuff. Nuke seems to work, and then this one's super elaborate. This one's probably closer to 3D equalizers, gives you all these different values. So these, as I say, all the different lens models, I just go with nuke. It seems to work. Okay, I'll stop the video now.